Mark, I'm going to kick it over to you first. We did have a comment question come in relating to IoT endpoint management from the perspective of also plugging in the needed chain of CA certs. I know you could, it's a little bit lengthy. I know you've read it on the back end.
Yeah, exactly.
So if you want to kind of add some color there and kind of talk about that topic for a few minutes, that'd be great.
Sure. So typically at the manufacturing side, it's a simple story in that when we're establishing a PKI or if we know we have multiple PKIs. And I'm muted. All right, there we go. What I was saying is it's actually really two different stories. At the manufacturing side of things, we know that the need to establish a set of trusted certificates and chain is fairly easy for us to do, and we can populate that in devices. It's more difficult down the road when we have chains that are updated, or we may need to incorporate new things. And one of the things that we can do early on is to facilitate a code signing perspective. And with that, what we can do is make sure that if we have a trusted chain down the road, that we can distribute that in a secure way. So a common way of doing that is through an SST or a trust list. And essentially what it is a set of root and intermediate certificates that we can cryptographically sign. And that can then be validated by our devices, and they can then bring those in as new trusted roots. So if we're needing to establish a renewal for our CA, make sure our devices can update, or if we're trying to establish a new PKI 20 years down the road, we can do that as well. That'll give us the capability of really addressing, populating the trust chain into devices that have already been deployed.
Yeah, I think it's it's a combination of keys that you put on the device, right? And how that happens, we've touched upon several ways to do it during the case studies. Sometimes it's the devices arrive empty and are provisioned with key materials. Sometimes they generate their own key materials. Sometimes they, you have like a generic or a production firmware load, and the only thing that does is to burn the keys for the real firmware image into the chip, so that then from that point on you have a secure boot where the chip only loads firmware that it can verify the signature of against that key that was burnt in the factory. And so having that root in there is really the stepping stone, the important part of anything you build on top of it in terms of updating, in terms of rolling algorithms or rolling keys. And having a secure channel into, for instance, the certificate trust store of a device or the keys that it trusts for code signing is very important. I think there is a lot. I like to see PKI as a closed system. Right, it is the trust store against the certificates that live in there that are ultimately trusted, and that trust store should not be too large. And for instance, we have on our Windows PCs and Macs and phones, we have a lot of certificates in those trust stores. And in the way that X509 certificates work, they are not restricted as to what they can be trusted to authorize. Right, and so a story I'd like to keep in mind is, why did a SCADA system that runs a ultracentrifuge in Iran, why did that trust a code signing signature from a device manufacturer half the world away to sign a piece of software that ultimately turned out to be compromising that installation? Right, you can think of that what you will, but ultimately, keeping that trust too wide is not a good idea, and so it's cutting corners by putting a generic operating system on that system, and a generic certificate trust store is probably not such a good idea.
Great, thanks, Sander, and thanks, Mark. I'm going to shift gears slightly. I have a couple questions for Ellen. It's kind of twofold. Why should we worry about lifecycle or updating identities and devices if it's secure from the beginning? And then to kind of follow up on that, as it relates to our zero trust solution, does it require a secure environment for initial setup?
Yeah, so let's start with the second question first. Start from the beginning. So a couple different ways to do this, and some of our customers that we've worked with recently have in their factory, they have a test stand or a firmware flashing stand or some workstation where, maybe, after they've done ICT testing and they're kind of ready to put firmware there, that we can work with that station as a trusted device, establish trust with that device from the PKI and the root of trust that we have built for the company, or the company has built, and then use that as a way to then do the kind of authentication and verification. So kind of using that workstation to establish the trust in the factory. And then secondly, around the why is it important to have life cycle updates if you're really building in trust and security from the beginning. I think we kind of touched on it in a couple different ways. It's just we don't know what's going to happen in 5, 10, 15 years with cryptography, with our algorithms, with other new technologies that are going to evolve, that are going to be able to get into these, in the physical hardware, or even just intercept the IoT systems that we're building now. So just it's more of a preventative, we don't know what's going to happen, but we have to have a process so that we can update the root and be able to update that in a very quick way if we need to do that, and then also update those crypto algorithms that we know are going to either become outdated, or people always talk about when quantum computing comes, and be able to break these algorithms that right now are sufficiently strong. They're not going to be that strong in the future when processing power increases. So those are kind of the things to think about is, do the right thing now, but also have to have a plan for being able to be robust over the lifetime of your device.